In this video, I will show and explain how to do the simplex method to solve the LP problem. And if you want to use the simplex method, we must make sure the objective function and the constraint are fulfill these three conditions. The first one is the objective function must be maximized, and the second is all the variables involved are non-negative, and the third one is the linear constraint equation symbol must be less than or equal. Okay, let's look to the example. As we can see, this example is not fulfill the condition because the objective function is minimized problem, and one of the constraint have large than or equals symbol. So one of the method to solve this problem is multiply these two error equation by -1. So the objective function will change to maximum, and the constraint larger than will change to less than or equal. Okay, so this is the new equation will look like. So the first step of the simplex method are change the equation to the standard equation form. So we throw the objective function right hand side to left hand side, and 2x will become -2, and y will become -y, and 3z will become -3z, and we add all the select variable. This select variable is depend on the number of constraints you have. In this question we have two constraints, so we add on the two select variable. After that we change the constraint to the equal symbol. So if the equation become the equal symbol, we need to add on the select variable to make the equation become equal. After we get the standard equation form, then we can proceed to the step 2. Step 2 is create initial table, and the initial table is based on the standard equation form. First we write down the basic variable, the select variable, and p, and the column will be the variable of the objective function like p, x, y, z, s1, s2, and the solution. After we get the initial table, then we can proceed to the step 3. The step 3 is check the optimality. If not optimal, then perform the pivot operation. So how to know whether the table is optimal? We can look at the row p. If all of the value of row p is positive, then it means the table is optimal. But in this question we got 3 negative value, so which means this table is not optimal. So we need to do the pivot operation. First we find the most negative at the row p, which is -3. So we highlight all the column become the pivot column, and we divide the solution by their own pivot column, then divide by 2 equal to 5. Divide by 1 equal to 8. Then we find the most minimum positive value, which is row 1, because the most minimum at row 1. And we highlight it to become the pivot row. And also we need to find a new pivot row by dividing their pivot column. Like this, in this case, the pivot column is 2, so this all row member must be divided by 2, which means 1 divided by 2, 3 divided by 2, 2 divided by 2, and so on. And so this will be the output: 1 divided by 2, 3 divided by 2, and this will become 1. And as you can see, this z is entering, and s1 is already exit. So the z is here and s1 is exit. So after we get the new pivot row, we also need to find the new s2 row and new p row. By use this formula, the new s2 is equal to s2 minus the new pivot rows times the pivot column. and this is S2 row, so we'll use the S2 value, S2 row minus the pivot column. Pivot column is 1 multiply the new pivot row, and this will be the answer. And also for the row P, we use the row P minus the pivot column. Pivot column is -3 multiply the new pivot column, and this will be the answer. And these two answers will be updated to the new table. And so this will be our output, and so this will be our pivot row, and we can know this x2 will be exit, and x will be entered at the new table. So now we update the pivot row to become new pivot row by using this formula. All pivot row divide the pivot element. The pivot element is this 1/2. So which means this all row must be divided by 1/2. And so this will be the answer. And also we need to update for the row Z and row P. So same as just now, we did the new Z equal to Z minus the pivot column multiply the new pivot row, and this will be the answer. And also this will be the answer. So we update the table. So now we get the new table. So like just now, if we get the new table, then we treat it as the initial table. Then we check it for the optimality. If optimal, then this answer will be optimal. If not, then do the operation again. And in this table, we can see all the row P is positive number. So which means this table is optimal already. So we can know the P, the most optimal P will become equal to 18, and the X will equal to 6, and Z will equal to the 2. And the basic variable for this table is Z, X, and P, and non-basic is Y, S1, and S2.